All right, we are continuing on solving exponential and logarithmic equations. We're on example 3, and it says solve log of 4x minus 7 equals the natural log of x plus 5. Since this is natural log, we know that this has a base e. So natural log always has base e. So since this equation has a natural log on both sides, we can drop the log like the property says. Go back to your notes, refer to your notes always, and it says that you can drop the log and solve the equation. So 4x minus 7 equals x plus 5. From here, it's just a simple two-step equation. I'm going to subtract x from both sides. 3x minus 7 equals 5. Add 7. I don't know why I put a 5 there. Let's see. Add 7 to both sides. And that equals 5 plus 7 is 12. Divide by 3, x equals 4. All right, it's easy to check. Just plug this in. X is 4, so 4 times 4 is 16. 16 minus 7 is 9. So the natural log of 9, does that equal the natural log of 4 plus 5? 4 plus 5 is 9. So the natural log of 9 equals the natural log of 9. Quickly, you can check that and make sure it's correct. Example 3b. Log base 2 of 5x minus 17 equals 3. So this is a logarithmic equation, but it only has a logarithm on one side. So think about the different things that we've learned and what we can use to solve this equation. So if you remember, exponential equations are inverses of logarithms. So what we might do is set each one of these to a base of 2. So basically, let what we have become the exponent, and that may help us. So let's say if we have base of 2, and we're going to raise this to the log base 2 of 5x minus 17, and then we have to do the same thing. Remember, it's an equation. Whatever you do to one side, you do to the other side. So we're going to have a base of 2, and the right-hand side is 3. So that becomes your exponent, just like this becomes the exponent on the left-hand side. Now, why did we use 2 as the base? Because now we've got 2 log base 2. And again, that's going to cancel and give us 1. So now we just have 5x minus 17. And then you can evaluate 2 to the third power. 2 to the third power is 8. 2 times 2 times 2. So that's 8. And then add 17. 17 plus 8 is 25. Divide by 5. X equals 5. Again, we want to check that, so plug it in to check it. So we're going to say 5 times 5 is 25. 25 minus 17 is 8. So what is log base 2 of 8? You can evaluate that very quickly. Knowing your properties of exponents, you probably already know that, but it doesn't hurt to double check. So we're going to go log base 2 of 8. Basically, 2 to what power gives you 8? And that is a 3. So you can see that if you evaluate the left side, 3 equals 3. And again, you can quickly check and make sure that you did that correctly. So just to recap here, this only had a logarithm on one side. So we rewrote it as an exponential equation with the same base as your log base here, so that would cancel and give you 1, and then you could still set it equal and solve as a simple equation. Example 4, solving an equation with an extraneous solution. So remember, in previous lessons, an extraneous solution is a solution that is derived from the original equation when you solve it, but when you plug it in to check it, it doesn't work. So that means when you solve these, make sure you check them to see if you have real solutions or if you have an extraneous solution. Remember, an extraneous solution is a solution that you have to kick out because it doesn't work when you check it. All right, so solve log of 2x plus log of x minus 5 equals 2. So we can see that this is an expanded logarithm on the left-hand side. So the first thing we need to do is condense this logarithm using our properties of logarithms. So let's rewrite this as log of, I'm going to have 2x. Remember, addition comes from the product property, so we can write this as 2x times x minus 5. Refer to your notes where it talks about your three properties. We had the product property, the quotient property, and the power property. And those are all in your notes, maybe in the last lesson. All right, so we have log of 2x times x minus 5 equals, we still have 2 on the right-hand side. Now that we've used properties of exponents to condense this, we need to think about what it means to be a common logarithm. So this does not show a base, so that means it's a common logarithm, and it's assumed to be base 10. Since we only have a logarithm on one side of the equation, we can do like we did in the last example and use a common base to set these as exponents, to rewrite this as exponents. So since we have log base 10, or our common logarithm, we're going to say 10 to the power of log 2x times x minus 5 equals, and we're going to do the same thing to this side, 10 to the second power. All right, as long as we do the same thing on both sides of the equation, it means it's still equal, it's still true. All right, so if we have log base 10, so we have 10 raised to the log base 10, so that's going to cancel the logarithm. So we're going to have 2x times x minus 5, and 10 squared is 100. 2x times x is 2x squared. 2x times negative 5 is negative 10x. I'm going to subtract 100 from both sides and set this equal to 0. Why? Because we have a quadratic equation, which means now we're going to have to solve a quadratic equation. How do I know? Because this is x squared. We've already studied quadratics back in a previous chapter, so you should remember how to do everything to do with quadratics. You're still going to have to know. All right, so the first thing I want to do is factor out of 2. So I'm going to have 2 times x squared minus 5x minus 50. Okay, and now x squared minus 5x minus 50 can be factored. The 2 kind of falls off. It's just 2 cannot equal 0. And if you think about the zero product property, 2 times this equals 0. 2 cannot equal 0. So it just made this side 2 times larger. It didn't really change anything when it's equal to 0. So we're going to reduce that by 2 and then factor x squared minus 5x minus 50. So this can be factored into 2 binomials. X times x is x squared. What multiplies to give me negative 50 and adds to give me negative 5. So I know 10 and 5 multiply to give me 50. I know I need a negative 50, so one has to be negative, one has to be positive. And then since the negative 5 in the middle means my bigger number has to be negative. All right, once I get to here, I can say x minus 10 equals 0. And x plus 5 equals 0. Again, I'm using the zero product property. So x equals 10. Subtract. X equals negative 5. All right, so just knowing logarithms, I'm going to assume the negative one is probably the extraneous solution, but we do need to check both of these to see which one is the real solution and which one is extraneous. So if we do that, we're going to go back to the original equation. So I'm going to have log of 2x. So I'm going to have log of 2 times 10 plus log of x minus 5. X in this case is 10 minus 5. Okay, does that equal 2? All right, so it's going to be log of 20 plus log of 5. Again, does that equal 2? Remember, properties of logarithms say this addition came from a product property, so I can say log of 20 times 5. It's just using my properties of logarithms. So it's going to be log of 100. Does that equal 2? Well, this is log base 10. So 10 squared equals 100. Okay, if you're not as familiar with that, you can always quickly type it in. What is log of 100? 2. So does 2 equal 2? Yes, so that means 10 is a true solution. All right, negative 5. Let's do the same thing. So we're going to have log of 2 times negative 5. And then plus log of negative 5 minus 5. All right, we know we're trying to set that equal to 2. So let's just evaluate the left-hand side and see what we get. All right, so 2 times negative 5 is negative 10. So we've got log of negative 10. And then plus negative 5 and negative 5 is negative 10 as well. Because negative 10 is not defined, okay? Remember, you can't do logarithms of negative numbers. That means negative 5 is not a solution. So just kind of like what I said, negative 5 is going to be your extraneous solution. It is a solution that we got when we solved the quadratic equation or the logarithmic equation to start with. But when we plug it back in, it does not work. So you only have one true solution, x equals 10.